they want us to write this in terms of a single sine, cosine, or tangent. And so if you have your trig identity sheet, you can see that let's call pi over 2a and let's call pi over 3b. So you'll see that you have sine a cosine b minus cosine a sine b, and that should ring a bell to you. And that if you look at your sum and difference identities, there's a sum and difference identity that says exactly that. So here's the formula that you might see, you might have written down. It's this one. The sine of x plus or minus y is equal to the sine of x, the cosine of y, plus or minus the cosine x sine y. And that means that the plus, when it's a plus there, it's a plus there. So do you see which one it is?
Minus.
See how it's got the minus?
Yeah.
So
since it's got a minus,
pi over 5?
It's going to be the sine of, right, it's going to be whatever a plus b are, or, I'm sorry, a minus b are. So a is that and b is that. And then simplify that. Well, first of all, do you understand how I got to that step? So then to add like terms, I'm going to have to get common denominator. So I multiply this by 3 over 3, and I multiply this by 2 over 2. So that's 3 over 6 minus 2 over 6. 3 pi over 6 minus 2 pi over 6, which is just, what's 3 minus 2? 1. It's just the sine of pi over 6.
So then,
which equals, by the way, we know what that equals because of the unit circle, but they don't want us to say what that equals. They want us to write it as a single sine, cosine,
so
or
they just want us to
tangent.
get down to that.
Yes. So here's another problem. Similar thing. If you see this, it might look like a big old mess to you, but if you remember your trig identities, you know that this was one of your trig identities in the sum and difference. And there's your sum difference identity for a tangent,
So
sum
that
of
would just be tan minus
tangent of a sum
tangent
of angles.
50 minus tangent 30.
See how it's a minus on the top?
Yeah.
Which means it's going to be a minus inside
So
the
it
parentheses.
just become tan of 20 degrees.
So this equals the tan of, remember what our x, this was our x and this is our y in this case. So it's the tangent of 50 minus 30, which is the tangent of 20 degrees. And that's your answer. Let's try this one now. Same deal. Write it as a single sine, cosine, or tangent function. Now you might want to like plug in sine squared or something, but that's not going to help. What is going to help is looking at your double angle identities. And the double angle identity, if you look at your sheet,
That's one of the equal to ones, right? It's just going to be,
yeah,
right there.
cosine of 2x equals
14 pi over 6.
2 cosine squared x minus 1.
So then wouldn't that just be cos of pi over 3?
Well, they want you to write it as a single, so let's just leave it like that.
Oh yeah, because you're not getting the value. You're just
Yeah,
getting
we're
the
not trying to get the value.
Okay.
You don't have to simplify that anymore because they just wanted you to write it as a single one. Let's try just one more. Let's do that last one so that we have them all.
Okay.
So
you try.
3x cosine 3x.
Can you tell what we have? Doesn't that look kind of like the 2 sine?
It kind of does.
Do you remember 2 sine x cosine x? Do you remember seeing that once before or once or twice?
Yeah,
That's a pretty popular one.
That was one of the
This
double
is
angles, but
this is
it's got
the
3
sine of 2x.
Yeah.
1. Can you see that that's what I have here?
Right, but we have the 3's.
Can you see that I've got 3x instead of x?
Yeah.
Oh, tricky.
So what am I going to plug in for x?
3.
I'm going to plug in 3x instead of x.
Therefore, it'd be sine 5x at the end.
Not 5x because I'm multiplying them. So let's carefully use substitution. This equals the sine of 2 times, what am I plugging in for x?
3x.
What were my x's here? It was really 3x, right? So it's equals sine 2 times 3x. So it's the double,
Sine 5x.
not 5x,
6.
6.
because this isn't being added, this
like
is
that.
being multiplied. This is equal to the sine of 6x.
Mhm.
And that's your answer.
Okay.